Good morning, everyone. I wanted to make a screencast covering some of the odds and ends of systems that we haven't talked about, but that we need to talk about. And I wanted to get a little running start into tomorrow or the next day's lesson. Let's look at this first one. This is a system that has a quadratic involved in the system that we're going to need to solve. Let's take a look. A farmer has 200 yards of fencing to build 3 identical pens for his herd of pangolins. If you haven't seen a pangolin, you should look up a pangolin. They're very cute. He wants to have 1,250 square yards total for the 3 pens. Now, the first part of this, I've given you a diagram here on the right. If you take a look right here, this diagram is of the dimensions for these 3 pens that I want to build. It says, explain the meaning of the equation 2x plus 4y equals 200. Well, again, we're told that we have 200 feet of fencing to use to build this shape on the right. All right? Now, I know that I need to have a bottom and a top to the pens, and I need 4 walls to divide the little rectangles, correct? Well, if you think about this, these lengths all have to add up to 200. So the 2x plus 4y, that represents all of the lengths that will make the side walls of these pens, right? And since I only have 200 yards of fencing, that's why it equals 200. Now, if I look at the next part of this, what is the meaning of x times y equals, what is this, 1,250? Well, again, if I think about area of a rectangle, isn't area length times width? So in this equation right here, x times y, well, those are the length and the width of a rectangle, of the big rectangle, and I'm told that I want to create a rectangle that has a total area of 1,250. So I know that the product of x and y is just the area. Okay, now let's almost right. In part C, it says isolate the variable y in part A. So if I have 2x plus 4y equals 200, to get y alone, I don't know why these little red strips are coming in here. It's awkward. Again, I know I'd subtract the 2x to the other side. So subtract 2x, subtract 2x. So I get 4y equals negative 2x plus 200. Right? Divided by 4, I get y equals negative 1/2 x plus 200. Plus 50, right? Sorry. All right. Okay, so I've done part C, right? Now let me just take this answer, and then I'm going to get rid of the rest. So here's my answer to part C. Now, why would I do that? Well, again, the question that I'm really wanting to figure out here is, what are these dimensions, x and y, that would give me an area of 1,250 square yards, but use up all 200 yards of fencing? Well, again, if I take a look at this, the first equation in A and the second equation in B, I see 2 variables and 2 equations. I know I could solve for those missing dimensions. But all I want to do is using substitution. In this case, I have to use substitution. It would be impossible to use elimination because of the math that's going on between x and y in the first equation, which is addition, and the math that's going on between x and y in the second equation, which is multiplication. You couldn't do elimination here. So substitution is the only method I can use. Okay, well, to use substitution, I had to get the letter y alone in one of the equations, and I got the y alone in part C. And now by doing that, I'm going to take the y in the second equation, part B, the x times y equals 1,250. And now I can substitute this expression right here in for this y on this side, correct? So if I did that, I would get the equation x times negative 1/2 x plus 50 equals 1,250, right? Now, as you can see, I've created a single equation with just the letter x in it. I know I can solve. So let me clean this up a little bit. All right, so now that I've cleaned this up, I'm going to do a little bit of math here. I'm first going to have to distribute this x to both terms inside the parentheses to get rid of the parentheses. If I do that, I get negative 1/2 x squared plus 50x equals 1,250. I'm not a big fan of fractions, so the next thing I'm going to do is I'm going to clear the fractions by multiplying every term by 2. I get negative x squared plus 100x equals 2,500, right? Now, I need to move everything to one side, but at the same time, I want to have a positive x squared. So I'm going to move the x squared and the 100x to this side, giving me x squared minus 100x plus 250, I'm sorry, 2,500 equals 0. Now I'm going to try and factor this guy. What multiplies to give me 2,500 but adds to give me 100? Well, golly, I think that's just 50 and 50. So that factors into a nice and tidy x minus 50 and x minus 50, right? And again, to check it, I would FOIL this out. It would work. And so I would get, from the first parentheses, x would equal 50. And from the second parentheses, I get the same answer of x equals 50. So there's only one answer for x. The dimension has to be 50 yards across. Now, to find y, I'm going to have to go back up and pick either of the two equations that I had, and here in part C, or here in part B, or even here in part A. Right? I could use any of those three because I have both letters x and y. I think C would be the easiest just because y is already by itself. Plugging in that 50 I got for x, I get y equals negative 1/2 times 50 plus 50. And when you do that math, I think you just find that y would have to be 25 yards. Okay? And so you'd want to write out in English, what are the dimensions of the pen? The dimensions of each pen would be, let's see here, well, again, the whole pen, part E, the whole pen would be 50 yards by 25 yards. And then each pen, well, if I took 50 and divided by 1, 2, 3, 50 divided by 3 would be the dimensions of each pen from here to here, right? And let's see, what is 50 divided by 3? 50 divided by 3 would be, well, 3 goes into 5 once with 2 left over. 3 goes into 2016. So 16 2/3 yards wide would be the dimensions of each of these pens right here, right? And that's the answer to part F. And that's just one example of where we have a system that involves nonlinear functions or equations like a quadratic. Now let's switch gears and talk about systems of inequalities. I know that an inequality is all about the shading. So what about a system of an inequality? Well, a system of an inequality is just the solution to a system of inequalities where what I'm looking for is basically the overlapping shaded region from each inequality, right? So take a look at what I've got here. I've got this system right here, all right, where I've got a quadratic and a line, okay? So the first thing I'm going to do is graph, say the quadratic. Doesn't really matter which one you graph first. But if I've got y is less than negative x squared plus 4x plus 1, I'm going to graph this this quadratic related equation and then decide on the shading. So the first thing I need to do again is find the vertex. I know h equals negative b over 2a. So that would give me just 2. To find the k value, I would plug this 2 back into the original problem. So I get k equals negative 2 squared, plus 4 times 2 plus 1. So k would equal, let's see here, negative 4 plus 8 plus 1, so let's see here, that's 5. So I know my vertex is at the point in 2, 5. All right. Let me erase this, and then we'll go from there. Now, since my vertex is at 2, 5, right here, I now need to get some points on each side of this vertex. Now, keep in mind, I know this parabola better be frowning, right? So I'm just going to pick a point, say, one space to the left of 2, like 1, right? And I'm going to put that 1 into the equation and solve for the y value. Actually, I'm a bad boy. Let me write this using this vertex. I know the vertex for me y equals negative parentheses x minus 2 squared plus 5, correct? If I plug in a 1 in, all right, for x, that would give me the y value for that point. So I get 1 minus 2 squared plus 5. So I get y equals, doing the math, I would get 1 minus 2 was negative 1. Negative 1 squared is positive 1. But then positive 1 squared is negative 1. And negative 1 plus 5 is 4. So I know the point immediately to the left of the vertex is 1, 4. And graphing that out, I get this point right there. Now, because of mirror points, I know that there must be a mirror point just at 3, 4. And I get my parabola now. Now, I know that this parabola should be a dashed parabola, agreed, because of the less than, but not less than or equal to, right? So I get this parabola right here. Now, because I have more than just one shaded region to consider, I don't shade in the whole thing, right? Because that looks hideous, right? Okay? So instead of doing that, I'm just going to use some system to tell me which way to shade. Now, because I want to do y is less than negative x squared plus 4x plus 1, well, if I think about this, if I were going to shade, would this point be right here, would this point be less than or greater than the parabola? Well, that looks like it's above the parabola, so that would be greater than. So this point would be a bad point, right? In fact, all these points right here would be above the parabola. So that must not be where I want to shade. I want to shade all the points that are less than the parabola, right? Well, I think that would be all the points that are inside the parabola. So in here. So I use these little arrows to show what I want, okay? Right? Now, you don't have to do my method, but I like using the little arrows. All right, so I'm done with that, with the parabola. Now I've got to consider the line. So let's take a time out while I clean up my board. And now let's graph my line. All right, to graph my line, y equals 2/3 x minus 5. Well, I know the y-intercept for this guy is 5, so it's down here. And my slope tells me to rise 2 and run 3 spaces to get to my next point. And I can keep doing that until I get to this right here, and I get this line right there, right? Now, would you agree that I was a little bit cavalier in my approach to this, because I didn't even consider whether it was dashed or solid. I got lucky. I got really lucky because it was greater than or equal to. All right, so it should be a solid line. Now to figure out the shading for him, again, I've got my line right here. So I want to shade all the y values that are greater than the line. So it means above the line. Well, if this is my line, that would be up here, correct? Right? So then, what that means is the shaded regions that overlap between my parabola and my line would be this shaded region right in here. Would you agree? And I wanted to do my highlighter, but my computer doesn't want to work. But you would get something that looks like this. And I've just done a system of inequalities where I had something, a line and a parabola. Now let's look at one where you might have more than 2 inequalities, where we have, say, 3 inequalities. And I'm just going to do a line, and I think a system of 3 lines, and I think you'll get the idea here. All right, so the first one I have is x is greater than negative 3. Well, again, I know that x equals negative 3 is a vertical line, so I'm going to draw my vertical line in here. It should be dashed because of the greater than and not equal to part. I now have to do the line y equals, and I'm not going to do the shading. Greater than negative 3, this says shade all the x's where all the points whose x's are greater than negative 3. Well, that would be to the right of this line. So I'm going to draw 3 little arrows like that. Now I'm going to do y is equal or less than or equal to 1. So that would be this line right here. Agreed. And the shading for that will be below. Okay. And so I draw 2 little arrows like that. Notice, I could put an arrow down here, but why? I know that this region right here, he's not going to be part of the answer because he's not going to be overlapping for the red graph, right? My vertical line. So why put an arrow there? Not necessary. And then for my last inequality, I've got 2x minus 5y is less than 15. To graph him, I need to get the y alone. So I'd subtract 2x, I get negative 5y is less than negative 2x plus 15. I would now divide by negative 5, so I get y is, that's right, greater than, because I'm divided by a negative, 2/5, because the negatives cancel, x minus 3. Okay, so for this guy, to graph this inequality now, I get a y-intercept of negative 3. All right, my slope tells me to rise 2 and run 3, so it'll be up 2 and right 3 will be right there, and then rise 2 and run 3, that would be right here, and then drawing this line in, that would be a dashed line. Okay, looking at this inequality, I want to shade all the y's that are above the line. Is this above the line right there? No, that's definitely below the line, so that's not the region I want. I want above the line, so here. So I think what you can see is, when I graph this, the system that would be, the little shape that's overlapping would be this triangle in here. Alright, does everyone see how that triangle would be my solution to this system right there? And I've just done that system. Hey folks, thanks for your patience, and we'll see you tomorrow. Bye.